Okay, ladies and gents, in this video we're going to be talking about proofs. So the first thing you should always do is look at the instructions. Fill in the missing statements and reasons in the following proof. Got it. So what we have here is called a two-column proof. Before we get started on my statements and the reasons, I'm going to look at the figure that I have, which looks to me to be a quadrilateral with the diagonals drawn inside of it. Okay. Then I'm going to look at what's given to me by the problem. What information do I know without having to think about anything? Well, I know that segment ST is congruent to TQ, segment PS is congruent to segment QR, and angle TSR is congruent to angle TQP. And what am I trying to prove? I'm trying to prove that PQRS is a parallelogram. Okay, so a special type of quadrilateral. Now I'm going to check out my two-column proof. For every statement that we make in geometry, we have to have a reason to back it up. And no, you can't say that angle's 90 degrees because it looks like it. That's not a good enough reason to back up your statement. Now, we have to go in order. So we're going to go to step 1, find the reason for it. Go to step 2, find the reason for it, and so on until we get to the end and the final statement, which is number 7, and the reason to back it up. So let's see how we'll start this. Let's start with the first statement. Segment PS is congruent to segment QR. Wait a minute, that sounds familiar. It's right here. It was given to us, so that's always the best and easiest reason. How do you know this information? Well, it was given to me in the problem. So with every proof, you're going to start with the information that's given to you. And what you're going to end with is this piece right here, what you're trying to prove. So I know that my first statement is going to be one of my givens, and my last statement, statement number 7, is going to be PQRS is a parallelogram. So we can see the starting point, and we can see the end, but how do we get from the beginning to the end? And now we have to go back to the top and continue with the second statement. Segment ST is congruent to segment TQ. All right, that's another given right over here. So that's our reason. It's given to us in the problem. Now, something that you want to get in the habit of doing is every time you read a statement and you provide its reason, make sure that you mark it up in the diagram. Okay, so for the first one, PS is congruent to QR. We want to make sure we mark it as congruent. Right. For the second one, segment ST is congruent to segment TQ. Now, since I already used one tick mark, I'm going to use 2 tick marks on these segments. Now, the third one, angle TSR is congruent to angle TQP. What is the reason for that? It is given to us again. Okay, now I'm going to mark it in my diagram, so I'm going to start TSR, so it's this angle right here, and then that's congruent to angle TQP, and that's this angle right here. Okay, perfect, and that is given to us. All right, statement number 4. We are past our givens, and now we have to start doing some thinking. Angle QTP is congruent to angle RTS. First, I'm going to identify where those 2 angles are. So angle QTP is right here. I'm going to put 2 arcs on it, and that should be congruent to angle RTS. Aha! Well, these are non-adjacent angles that share the same vertex. So they are vertical angles. You always know that vertical angles are congruent to each other, and they kind of look like 2 V's touching at their vertex. All right, the next statement. Triangle QTP is congruent to triangle STR. Aha. Now, this is a triangle congruence statement. So that means we have to use one of the 5 triangle congruence postulates. And Ms. Sanchez mentions that they are SAS, SSS, ASA, AAS, and HL. Let's find out which one we're going to use here. So the first thing that I do I need to identify the triangles. I need to see which ones I'm talking about visually. So what I usually do on my paper is I highlight the two triangles. So the first one is triangle QTP. I'm just tracing it. And the second triangle is triangle STR. Aha! Now I have to see in each triangle how many angles do I have and how many sides do I have to work with. So in each triangle I have 2 angles and 1 side. Yep, 2 angles and 1 side. So either I'm going to be dealing with AAS or ASA. Now in this one, because the side in each triangle, the side right here that I'm highlighting, is between the 2 angles, it has to be ASA because the side is between the 2 angles. So the reason for that is the angle, side, angle, congruence, postulate. Oof, I had to write really small and messy right there. But it's the angle, side, angle, congruence, postulate. Okay, now let's move on to statement number 6. Well, statement number 6 doesn't exist. So let's look at the reason. So corresponding parts of congruent triangles are congruent. Well, for 2 congruent triangles, there are actually 6 corresponding parts. So it's going to be really hard to identify which 2 of the 6, or excuse me, which one of the 6 in each triangle I'm going to use for my pair right here. Now, in order to find out, I need to look at statement number 7, what comes after it. Because statement number 7 is going to use statement number 6 in order to complete it. Okay, so statement number 7 is PQRS is a parallelogram, and the reason is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So I can see here that they're saying if both pairs of opposite sides of a quadrilateral are congruent. Well, let's look at my quadrilateral PQRS. Now I'm thinking to myself, do I have both pairs of opposite sides marked as congruent? And I'm looking at the tick marks, and it looks like I just have PS is congruent to QR. I don't have that both pairs are congruent to each other. So that means in order to say PQRS is a parallelogram in statement 7, in statement number 6, I need to state that the other pair of opposite sides in this parallelogram are congruent. And by that I mean segment PQ is congruent to segment SR. Okay? And I'm going to mark that in my diagram. Segment PQ is congruent to segment SR. Now I can say in statement 7, or excuse me, reason 7, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Yes! Got it! Don't stop that, don't, hey!